Hello, I welcome to this lecture and please subscribe to this channel if you didn't. And this time I just talk on Young's double slit experiment. It's a purely optical phenomenon called interference. And you've got two slits. Slit width is just D. This is a source. And you've got a screen where you can have interference pattern. Very nice bright and dark fringes. Alternative bright, dark fringes, which is observed on the screen. Now the slit width is D. And the screen is placed at the distance D from the slit. Now let me say I have got a point P. It might be having a bright fringe or it might be having a dark fringe, but let me say X is a distance from the center to that P. So I might have dark or bright fringe depending on the path difference between BP wave and AP wave. And you know the difference, the path difference young lambda for the bright fringes. Path difference between two waves should be equal to young lambda to get the bright fringes. So that we will do it later. Now, very simple, I have to do some mathematics here. This is just D. This should be D by 2 because this is D, right? And now we've got two right angle triangles. One is AEP, is a right angle triangle. Now I apply the Pythagoras theorem. AP square is equal to AE square plus PE square. That is that with AP square is equal to this is nothing but D square plus this is nothing but X minus D by 2. So I want this D one, I want this one. This is nothing but the whole minus D by 2. That's why I have written here. Next, one more triangle I've got, that is BPF. Again, one more right angle triangle. I apply the Pythagoras theorem again, that is BP square is equal to BF square plus PF square. So that is BF square is D square plus PF is X plus D by 2. So now we have got X plus D by 2 square. I want to find what is the path difference. I'll equate with the wavelength of the light, and I know the condition for the path difference is young lambda for the bright fringe. So now what I will do is, I'll just take the difference, because I want the path difference as BP minus AP is nothing but the path difference. So BP square minus AP square is equal to this square will cancel. You have A plus B whole square, A minus B whole square formula. You use it, X square plus D by 2 whole square, so that will cancel each other. And you're left with the third term, that is 2 times X D by 2. Here also 2 times X D by 2. And got a minus, so it will become plus, because you're going to subtract this minus this. So finally we'll be having 2XT. That is going to be the BP square minus AP square. But I want what is the path difference between two waves, that is BP minus AP will give you path difference. So make use of A square minus B square formula. So BP plus AP into BP minus AP is equal to EXT. I want what is the path difference, that is BP minus AP, that's what I've written here, BP minus AP is equal to 2XT by BP plus AP. Now what I will do is I'll just assume, and it is known that the distance between two slits is very, very small compared to the distance between slits and screen. It may be 1 meter, the distance between slits and screen, and distance between two slits is very small. It could be 1 millimeter, it could be 2 millimeter. When you compare with a meter, 1 meter, this is very small. Hence what I can take is this BP and AP can be approximated to the distance between slit and screen. That's what I did. Here it is a D. So I want this one, which is equal to 2XD by the whole term. BP plus AP, which is approximated D for this condition, D plus D, XD by D. So this is what the path difference between two waves reaching at point P, BP and AP. That's all. Now, I know the condition for the bright fringe. The path difference between two waves should be equal to young lambda, then only I'll get the bright fringe at the point P. Now, for the bright fringe, maybe young bright, it may be young plus 1, it may be young plus minus 1, it may be first, second, or I generally say it is a young bright fringe. And for the young bright fringe, X and D by D, that is that with the path difference is equal to young lambda from the interference, and I want for the distance from the center to the young bright fringe, young lambda D by D, that is just distance from the center to the young bright fringe. Now for the next consecutive bright fringe will be young plus 1, right? This is young 1 and this is young plus 1, maybe young plus 2, and now I've got to write for young plus 1 the distance from the center to the young plus 1. The same equation I can use, I have to put young plus 1, that's all. What is the fringe width? Fringe width is just distance between two consecutive bright fringes. So now this is a bright center, this is bright, this is bright. For example, this is young bright fringe, this is young plus 1. So the distance between two bright fringes is going to be fringe width, that is beta. So that's what I have to do. I have to take the difference, Youngsian minus plus 1 minus Yaxen. So n plus 1 minus n will be 1, 1. So lambda d by d is going to be the fringe width. So that is a fringe width between two successive bright fringes. And if you do the same for dark fringes using another condition for the path difference, in case of dark fringes, you'll get the same. That's the bright fringes for two consecutive dark fringes. So the bright fringe, a dark fringe doesn't matter. The distance between two consecutive or two successive bright fringes and dark fringes is same, and it mainly depends on the wavelength of the light you use. If you use a red color instead of a blue color, lambda will be more because the wavelength for the red is more. That means the fringe width, the width between two consecutive fringes will be more because they are directly proportional. And if you move this screen and slit away each other, instead of 1 meter, if you make it 1.5, obviously beta will increase. That means the fringe width will increase. And if you increase the d, that means if you increase the slit width to the distance between two slits, and obviously beta will decrease because they are inversely proportional. So thank you for watching this. Catch you next time.